Back on site today, we brought Zach out due to the concern with the wind conditions.
My role today as a visual observer, I will be watching the wind conditions, monitoring the airspace to make sure we have a safe flight.
Because we're so close to the airport, I've been in contact with traffic control and they've granted us access to fly the site. We're confident we can get the data we need and get the missions wrapped up today. Today, having Zach on site was a tremendous help. I was able to focus on the drone and not so much, air traffic. He was able to monitor that and make sure our mission was safe. So we're back at the office, everything went well. We're gonna get everything downloaded and pass it on to Brad and let him do his thing and get the final product ready.
So now that Justin's brought you the data from the field, can you walk us through processing?
I'll open up POS packs here and start a new project, check it against the known satellite and geodetic systems. These checks showing me that it actually georeferences with multiple satellite systems is a bit more comforting to me as well as to Dennis, knowing that our information is more accurate. It's truthful data and it's not just some arbitrary contours that it just generated.
Sure. Accuracy is key.
So the next step is going to go into MD Infinity, go to georeferencing. We will choose our LiDAR package, the MD LiDAR 1000. We will choose the MRS files and then choose the associated SBET file that we just generated using POSPAX. Here we'll keep it at 60-degree field of view. We are going to merge all of the smaller point clouds into one giant point cloud for us to utilize. We will add our coordinate for our output system, which is NAT 83, US foot, Louisiana South. We use GEO 12B at the moment. This first flight, we got the river right along here. Out of Trimble, we would start a new Civil 3D drawing. In Pix4D, we will add all of the images that we referenced earlier. It puts out a wonderful ray cloud with the photos that puts out a nice ortho mosaic. So then we have our georeferenced image behind our georeferenced point cloud. Engineers can easily turn the point cloud off and zoom in directly to an image if they have a question about a certain area. We'll go ahead and finish cleaning everything up, and then we would make our deliverables for our engineer, being the 3D surface that we would send out to them, as well as making our paper deliverables for our clients. Scale it down to the size and fit of the client's recommendations, have it signed and stamped by our professionally licensed surveyor, Dennis, and send it out to the client.
In post-processing, the data came out really good. You have good point density. You was able to break through the marsh grasses. We did have a few hiccups with the weather, high winds, rain, lightning, but that's how it goes in South Louisiana. I think Justin did a great job on this project. Using the MD LiDAR 1000, we're able to capture accurate data way faster than traditional survey methods would have allowed. We're able to produce more accurate, more efficient projects, ultimately saving our clients money and moving projects along at a much faster rate.